So you've been using S3 for a few years now. S3 just works, and over time, more and more workloads move to S3. S3 scales to your needs, and you've added millions and even billions of objects. At first, you had one account with a few buckets. Now you have many accounts with hundreds or even thousands of buckets. And it's becoming harder to remember what each bucket, much less each prefix, is being used for. Then you're in a meeting, and someone says, we have some new regulatory requirements, and we need to make sure that all of the objects in S3 are encrypted. Oh, and we need to make sure that our objects are replicated to another region. Oh, and also we need to understand which buckets and prefixes are growing the fastest. Then they turn to you and they say, can we do that? Well, of course you can. And you probably already knew that. And today I'm going to show you exactly how. In this presentation, I'll show you how to verify the status of your objects and make changes on a massive scale. I'll go through 3 scenarios similar to the questions we had in our fictitious meeting, so you can see step by step how to manage your objects and analyze what you have. Welcome to achieving unparalleled scale on Amazon S3. Manage and analyze your data. My name is Lee Keir. My pronouns are she and her, and I'm a senior storage specialist, solutions architect with AWS. So let's look at our first scenario. The CISO calls a meeting and there is a detailed security review. The objects stored in S3 are subject to a wide range of regulatory guidelines. You need to provide proof that all the objects stored are encrypted. So in order to do this, we're going to use default encryption to make sure that all new objects are encrypted, S3 inventory to verify the status of the objects that currently exist, and S3 batch operations if we need to encrypt any existing unencrypted objects. Now I'm going to cheat a little bit here. I'm going to show you how to do this on one bucket, but by the end of this presentation, you'll know exactly which buckets you should be looking for. So S3 provides default server-side encryption at the bucket level. You set it up in your bucket one time, and then all new objects will be encrypted. Now, if there is a request that comes into your bucket that specifies the encryption to be used, then that request will be honored. But if there is no encryption in the request, then we will automatically use whatever you've configured, either SSE S3 or SSE KMS. So all our new objects are going to be encrypted, but we need to make sure that existing objects are also encrypted. To determine the encryption status of existing objects, we'll use S3 inventory. S3 inventory reports are a long-standing staple of the S3 data management toolset. S3 inventory reports provide valuable insight into the data currently stored in S3. Each inventory report can be configured to include object metadata such as bytes stored, last time accessed, storage class, intelligent tiering access tier, encryption status, among many others. So reports can be scheduled to run either daily or weekly, and they can be created for an entire bucket or filtered by prefix. S3 inventory reports can be configured to output to CSV, Apache Orc, Apache Parquet, and those files, and they can all be then queried by tools such as S3 Select and Amazon Athena. So let's create an inventory report. We begin by selecting the bucket with which we wish to create the report on. When we select the Management tab, and down near the bottom of the page, you will see the inventory configuration. Here we'll be able to view existing configuration reports that have been previously configured on this bucket. And then we'll click Create Inventory Report. That will bring us to this page where we can then put in a descriptive name. We're going to leave the prefix field blank because we want to report on the entire contents of the object, of the bucket, and then we want to determine whether we want all versions or just the current versions. Now, if you need to make sure that all previous versions are also also encrypted, then you may need to look at this list and think about maybe perhaps deleting those previous versions. And you might do that with a lifecycle configuration. So then we want to define where our report will be stored. We're going to select a bucket within our account, but you may want to send this report to a specific bucket that you use for reporting. And then it's going to automatically append a bucket policy that will allow the S3 inventory service to be able to write this report to your bucket. Then we'll decide whether we want to have this report come either daily or weekly. And regardless of which one we choose, it may take up to 48 hours before the first report is generated. We will then pick our file format. In this case, we're going to pick CSV, and then we're going to enable the report. And finally, we need to pick which metadata fields we want to enable. And of course, we need to enable encryption. So now we've created our report, and we want to wait for it to complete its first execution. Now that our newly created inventory job has outputted its first report, we notice that we do indeed have several objects in our bucket that have not been encrypted. We would like to use S3 batch operations to encrypt these items, but first we need a simple way to filter out the objects that have already been encrypted from our report. There are several ways to accomplish this, and for more complex use cases, we might want to use a tool like AWS Athena, but S3 Select will fit the bill here nicely for us. So here we have an example of the AWS CLI to perform the S3 Select command on our inventory file, where we only get the rows where the 12th segment is not SSE. In our report, the 12th segment is the encryption status metadata field, and the value of not SSE identifies this as an object that was not encrypted by any S3 encryption options. Those encryption options would be SSE S3 and SSE KMS. So you can see by our restriction, we have our select statement, and then we're going to output to unencrypted-objects.csv. And so we have created our CSV file that we're then going to use as an input to our batch operations process. S3 batch operations provides a scalable way to execute many common tasks across millions or billions of objects. Because it's a managed service, it runs in the background and will self-throttle to prevent any impact to your performance. You don't have to write code, set up server fleets, or figure out how to partition the work and distribute it among the fleets. Instead, you create a job in minutes with a couple of clicks, turn it loose, and sit back while S3 uses massive behind-the-scenes parallelism to take care of the work. So here's how it works. First, you provide an input into the job, which could be a CSV or inventory report, and this identifies which objects you wish to modify. Then you choose your operation. Copy is what we're going to use. We're just going to copy the objects back to themselves. And because we have enabled default encryption, those objects will automatically be encrypted. We could have also chosen to use a Lambda function, which provides almost limitless capacity for data handling. You could also use other operations, such as replacing all the object tags or ACLs replace all the object ACLs or object tags. But do note that this operation replaces rather than adds to the existing configuration. You can also restore objects from Glacier or modify object tag properties, object lock properties, such as legal hold and retention date. And then Amazon S3 batch operations does the work for you. The selected operation takes place across each of the objects in the inventory file or CSV. And lastly, you determine where you want to view the results or track the progress. So here's a deeper view into the S3 batch operation job. Note the selection of the operation, the manifest, and the reporting location. The priority allows S3 batch operations to run tasks in parallel while allowing you to set your priorities for batch operations within your account. This API-driven approach makes granular, automated deployments of batch operations a breeze. So with this, we've satisfied our requirements and encrypted all objects in the bucket, and all new objects will be encrypted. So let's move on to our next scenario. Investors insist that all data be replicated to a separate AWS region. Data should also be protected against accidental deletion and rogue actors. Additionally, you need to show how quickly the data is being replicated. So to satisfy these requirements, we'll be using S3 replication, specifically cross-account replication, and also we'll be using S3 replication metrics to show how the data is being replicated. S3 replication is an automatic and asynchronous process that makes identical copies of your data, retaining all the metadata on the source object, including the create date and time, the version IDs, and the tags. So S3 same region replication, or SRR, is an S3 feature that automatically replicates data between buckets within the same region. And some use cases for this might be between a developer and a test account, or perhaps you need to abide by data sovereignty laws. With S3 cross-region replication, you can replicate objects and their associated metadata and object tags to another AWS region to reduce latency, compliance reasons, security, disaster recovery, and many other use cases. You can also replicate to a bucket with object lock enabled and set the default such that replicated objects are then locked at the destination bucket for the time period which is configured on the destination bucket. If you had a requirement for replication timeliness, you could use S3 replication time control to provide an SLA that 99.99% of all objects will be replicated within 15 minutes. So now let's take a closer look at how we can best use the capabilities of S3 replication for our scenario. So what we're going to do is we're going to take a bucket in region 1 under account A and replicate to region 2 in account B. So this is cross-account replication, and this will protect you against rogue actors. So how does it do that? So say a rogue actor were to get the credentials of your account A. They might try to delete all those objects in your bucket, but they would have no permissions to delete any objects in account B's bucket. You also want to consider using object ownership override. What this will do is that if, say, account C is putting objects into account A's bucket, when they're replicated, they will be owned by account B. That way you have uniform ownership of those objects. You also want to consider and make sure that you use the right storage class. The objects in the account B bucket are likely to be accessed much less frequently. So you might want to look at putting those into S3 standard infrequent access, Glacier, or Glacier Deep Archive. And since they are being used differently, you want to use a different and independent lifecycle policy. And finally, you want to make sure that you don't replicate delete markers. Previously, that was the only option, but now you can replicate delete markers. In this case, however, you would not want to do that, as you do not want to have accidental deletes replicated and deleted in your destination bucket. So previously, to get S3 replication metrics, you had to turn on replication time control. But now you can enable per destination level metrics and notification for each replication rule without turning on S3 replication time control. You can track bytes pending replication, the number of operations pending replication, and the latency between the source and the destination region for replication. And you can view all of these metrics either in the S3 console or in Amazon CloudWatch. You can also receive replication failure events to quickly diagnose and correct any issues. Replication failure notifications can be sent to Amazon SQS, Amazon SNS, and AWS Lambda. So we've satisfied the requirements for cross-region replication, where we enabled cross-account replication with object ownership override and to protect against rogue actors, and we enabled S3 replication metrics to see how quickly the objects are being replicated. So before we move on to the next scenario, though, I wanted to talk about some new S3 replication features. S3 replication now provides you the ability to replicate on one or more destination buckets at the same time, or across different regions. You can sync between two buckets such that writes to either bucket are replicated to the other bucket. And you could use this in an active configuration. So this would be a time when you actually would want to replicate delete markers so that you can keep these buckets completely in sync. You can even sync to multiple buckets in a region. And each one of these replication parts is configured independently. Say you already had replication set up between two buckets, and you wanted to add another destination. To replicate objects that were previously replicated that you now desire to replicate to a new bucket, or buckets, we recommend that you use a similar pattern that we used in our first scenario. You can use S3 inventory to identify the objects that you want to replicate, and then you can use S3 batch operations to either copy those objects directly to that same bucket, like we did before, which will trigger replication to all configured destination buckets, or you could copy the objects directly to the new destination. Now, the first option has the benefit of ensuring that New subsequent metadata updates will be replicated to all destinations, but you're also going to update the you have to update the date timestamp as well as replicating again to previously replicated destinations, which can increase your cost. So the second option is what I'd recommend, is save you on cost by replicating only to the destination bucket and doesn't change the date and timestamp on the first or second destination buckets. So now let's take a look at the last scenario. We need to prepare for a financial audit. We need to analyze how efficiently your S3 resources are being utilized. So I'll show you how to do this using S3 metrics and S3 storage lens to better understand your S3 usage. So we just talked about S3's new replication metrics, but S3 provides more Amazon CloudWatch metrics that can help you to understand and improve the performance of your applications. The first metric category is daily storage metrics for your S3 bucket. These metrics are reported once per day, and they give you access to the total amount of data in each storage class, as well as the total number of objects stored in each class. And these metrics are free to all S3 users and are on by default. The second type of metrics that are available in CloudWatch for Amazon S3 are request metrics. Requests can be monitored to quickly identify and take action on operational issues. As you can see, there are request metrics that count how many operations were performed against this bucket, prefix, or object tag. And you can see how many bytes were uploaded and downloaded or accessed via S3 select operations. And you can see both first byte and total request latency. Request metrics are available at 1-minute intervals after some latency to have them processed. And request metrics are billed at the same rate as Amazon CloudWatch custom metrics. These metrics do require customers to opt in. You can turn on these metrics in the S3 console. And by default, they'll report on all objects within a bucket, but you can also define filters for prefix or object tags. So that this allows you to track these metrics on perhaps in a workflow or application level. Now let's spend a moment focusing on S3 CloudWatch percentile metrics. These percentile statistics can help you to understand the distribution of a metric when you have a large variance in request patterns. They help you to identify the experience that most of your users see, highlight outliers, and avoid false alarms. By using percentile metrics, you'll be able to create alerts that eliminate the extreme outliers in a category, which in turn allows you to ignore certain extreme examples that may not be relevant to your application's user experience on the whole. For example, by focusing and alerting on a P99 value, you would eliminate the extreme example of, say, high latency that occurs less than 1% of the time, and may not be concerning for those isolated instances. Now, we can go to the P99.9 or P99.99 to further isolate those extreme examples and prevent inactionable alarms. So I'd like to talk about the next step in understanding your S3 data, S3 Storage Lens. S3 Storage Lens provides a single view of object storage usage and activity across all accounts in your organization, with drill downs to account, bucket, and even prefix level. S3 Storage Lens was released in November 2020, and customers love it. So first and foremost, S3 Storage Lens provides a large number of metrics, 29 in total, including both usage and activity. And I'll go into the specific list of metrics a little bit later in this presentation. But I wanted to call out that many of these metrics are brand new and have never been surfaced before by S3, and others have been provided before, but only at the bucket level. S3 Storage Lens provides aggregation levels from the highest level of AWS organizations all the way down to the very granular level of prefix. And because the data is pre-aggregated, customers can interact with reports and data sets easily and fluidly without having to wait for the computation time to count up the results. Metrics are updated on a daily basis. Think of it as a daily snapshot of how your storage and activity occurred by the end of the day. And the end of the day in this case is midnight UTC. You can store up to 15 months of historical data to analyze, enabling you to analyze long-term trends and patterns. Or even to time hop back to a previous day to see the snapshot of the usage and activity on that day. The centerpiece of S3 Storage Lens is a highly visual, interactive dashboard, which is embedded into the S3 console. It can be used to slice and dice and drill down and perform many other standard dashboard interactions on your data. I'll demo the dashboard in just a minute. By the way, customers who are not interested in using our dashboard, perhaps you have your own dashboard that you want to integrate with, you can receive an export in CSV or Parquet format of all of your metrics, and they can be delivered to a bucket of your choice on a daily basis. And finally, the recommendations are icing on the cake. They provide an interpretation of the metrics to help you flag outlier data points or to take action against a particular metric. So now let's take a look at how S3 Storage Lens works. To start, we wanted to make the configuration of Storage Lens extremely easy, but also to provide a high degree of flexibility. All customers receive a free default dashboard configuration at the account level. The free dashboard includes most of the features of S3 Storage Lens. It gives 14 days rather than 15 months of data, and it does not include activity metrics, prefix aggregation, or recommendations. And for some customers, this is the only dashboard that they'll need. But you can easily edit this configuration if you want to upgrade to receive additional metrics, prefix aggregations, and recommendations. You can also then add the optional metrics export. You have the option to create a custom configuration using AWS organizations, or if you want to scope your dashboard more narrowly, you can use specific AWS regions or buckets. In total, you can create up to 50 individual dashboards, so you can create an individual dashboard for each one of your teams. Once configured, S3 Storage Lens will provide a nightly aggregation of your storage usage and activity metrics. For analyzing your daily metrics, Storage Lens uses an interactive dashboard embedded in the S3 console. Here you have the ability to perform filtering and drill down across each level of aggregation. You can run long-term trend analysis on your metrics with up to 15 months of historical data. And the many metrics are organized into categories like data protection and cost efficiency to allow you to easily find relevant metrics. The metrics presented in the dashboard can help you to better understand your storage with summary insights like, what's my fastest growing bucket or prefix? Or how much total storage does my organization have? Storage Lens provides callouts for outlier data points based on 30-day trends so that you can investigate unexpected fluctuations in usage or activity. And finally, the dashboard provides contextual recommendations alongside your metrics so that you can take actions based on the metric. The metrics have been grouped into 4 main categories: summary, cost efficiency, data protection, and activity, which generally align to the types of analyses that customers will typically perform. If you look at the list of metrics here, you'll note that some of these metrics we saw with S3 metrics like total storage and object count. But in S3 Storage Lens, you can receive these metrics in aggregate across your organization or account, or at the prefix level, which was not previously available. On this list, there are some metrics you might not expect, like metrics that pertain to S3 feature utilization. For example, you can see the total number of objects that are of non-current versions. You can see delete markers, incomplete multi-part uploads, and the percent of objects that are encrypted. So this last one we could use in our first scenario to see which buckets are not 100% encrypted, and then we only have to investigate those. So now let's take a quick tour of the interactive dashboard. S3 Storage Lens dashboard is automatically created for every customer in your account. You have the option to customize the default dashboard by upgrading to get advanced metrics and recommendations, as well as enabling metrics export. You can also create additional custom dashboard views, including one for your entire AWS organization, specific regions, or buckets. The Storage Lens interactive dashboard shows a snapshot of your storage through the previous day. At a glance, you can see your most critical summary metrics. Or you can browse by category to see additional metrics related to cost efficiency, data protection, and activity. With over 30 metrics, you can select a primary and a secondary metric for deeper analysis. You can adjust the dashboard trend from the default view of 30 days to a longer time frame. Here you can see a breakdown of your usage by storage class and by region. The top end module shows the top accounts, regions, buckets, and prefixes. By default, it shows the top 3 items, but you can adjust this to show up to 25 items. The S3 Storage Lens includes several different features to efficiently navigate the dashboard and to quickly hone in on the insights that you need. Select any value in a chart to see additional info and to apply a drill down to repaint the entire dashboard with a filter on that value. Alternatively, you can choose the Analyze By option and select a dimension, allowing you to move to a new page of the dashboard to analyze this value by a new dimension for more granular insights. Several different visualizations are available, including bubble analysis, which allows you to see the relationship between 3 different metrics. Recommendations are displayed alongside metrics to emphasize outlier data points or to indicate opportunities to reduce cost or to apply data protection best practices. From here, you can take action on the console or you can access documentation. So that was our demo. Hope you enjoyed that. Today we used S3 default encryption, S3 inventory, and S3 batch operations to show how to make changes on your data in a massive scale. We used S3 replication to make 1 or more copies of our data and used replication metrics to be able to verify that. And then we used S3 metrics and S3 storage lens to gain insights into our data. Thanks for watching. Please complete your session survey and enjoy the rest of reInvent. Thank you.